Hello everyone, welcome to Smart Interviews. In this video, we are going to solve one more problem on trees from LeetCode. You can find the problem link in the description. Go ahead, click on the link so that we can solve the problem together. Also, I recommend you to pause the video here, understand the problem statement and come up with a solution on your own. Okay then, let's move forward and understand the problem approach. You are given an array of size n. Now from this array, you will have to create a maximum tree. What is a maximum tree? So from this given array, first you will have to select the maximum element. In this case, it is 15. You will make it the root of the tree, and then the rest of the elements which are on the left of 15 will be present in the left subtree. And the remaining elements will be present in the right subtree. Okay. Now again, what do you have to do is, in the left subtree, from this part of the array, you will select the maximum element again, which is 9. Now this will be the root of the left subtree. And the remaining elements on the left will be on the left subtree of this subtree. Remaining elements will be on the right. Same thing here. 12 is maximum. 11 will be on the left of 12. 8 will be on the right of 12. 5 is maximum. There are no elements on the left, so empty. 4 will be on the right. 6 is maximum. 2 will be on the left. No elements on the right. Then 4 will be the node. No elements on left and right. So done. Same for 2. Same for 11 and 8. So in this way, we'll construct a maximum tree. Now, how do we do this? Let's say to do this, we have a function. Let's say the function name is construct. What do we pass? We'll pass the array. Let's say this function takes array as the input and will give us the root of the constructed tree. So return type is node. Now tell me, simply passing the array, is it sufficient? If we observe here, we made 15 as the root. Now after this, to construct this left subtree, what do we do? It is also a tree. We are constructing from 0 to 4 index of the array. So this is very similar to what we are doing with the entire array. So we can call the same construct function on the left subtree to construct the left subtree from the left part of the array. In the same way, we can call the construct function on the right part of the array to construct the right subtree. Now, to get this node, which is maximum node for the left subtree, you will have to iterate only from 0 to 4, not further. How do we keep track of this? Initially, we'll have to find out the maximum element from the entire array. So let's say we are finding the maximum element with the help of a getMax function. We'll pass the array to this getMax. Now it will give us the index of the maximum element. Okay. Now, when you are constructing the left subtree, you should only iterate from 0 to index -1. Then again, for the right subtree, you should iterate from index +1 to n-1, right? So to keep track of the size or the indices from which index to which index we should iterate, we pass two more arguments or parameters, let's say low and high. Low denotes where we should start iterating, high denotes where we should stop iterating. So get max will pass the array, will pass the low, will pass the high. This gives us the index. Okay, then after this, we should create a node. With the element at the given index. Now this will be the root of our current tree. So let's say node root is equal to new node of array of idx. After creating the current root, we should create the left subtree and right subtree. So I'll call the construct function again with array. Low remains same, high will be idx minus 1. Right subtree, construct function with array. Low will be idx plus 1, high remains same. Now this construct function returns the root of the left subtree. So I should store it in the left pointer of the root. In the same way, I'll store this on the right pointer of the root. Finally, I'll return the root of the constructed tree. That's it. So recursively we can construct the maximum tree. Now, one thing is missing, base condition. Where do we stop? If you observe this, the array here is from 0 to 4. Here it is from 6 to 8. Here it is from 0 to 1, 3 to 4, 6 to 6, 8 to 8, 1 to 1, 3 to 3. But here, if we consider this, low will be 1, high will be 0. If we consider this, low will be 2, high will be 1. So, in both these cases, low is greater than high. So, we should stop if low becomes greater than high. What do we return back? Our function should return something of type node. Now, what does 4 contain in left and right subtree? It contains null. So we'll simply return null. That's it. So this is the approach. So let's go ahead and quickly code it up. Now before we write the code, I recommend you to write the code on your own. Let's start with the getMax function. So getMax will take a vector along with the low and high. Let's take a variable max, initialize it to low. Then we'll iterate from low to high. If current element at I is greater than current element at max, we'll assign current index to the max. Then finally we'll return max. Okay, so this is our getMax function. Now let's write the construct function. This function will take array, low and high as parameters. So if low is greater than high, we'll return null. Otherwise, we'll get the index by calling the getMax function. We'll pass the array, low and high. Then we'll create a root node. After that, we'll call the construct function to construct the left subtree. And we'll pass array. Then we'll pass low to index -1. Same thing for the right subtree. Array, but index +1 to high. We'll store this in root of left. We store this in root of right. Finally, we'll return the root. And from the given function, I'll simply make a function call to our construct function. I'll pass the given nums 0 and the length of the last index of the nums. I'll return the root node. Let's go and submit. Accepted. Okay guys, see you in the next video. Thank you for watching. Please like, share and subscribe for more such content.